Okay, well, apparently when I did my introduction to Sympy video, you might have noticed, thanks to the people who have emailed me about it, I'm sort of just now seeing this, or just not having time to fix it. Uh, the video marked Introduction to Sympy or something like that. Uh, that video was actually just the week 4 introduction video. And the way that I do my workflow for making these videos, the only way that possibly could have happened would be that I was not recording when I was making the video, which just means I was talking to absolutely nobody. Now, I'm always talking to absolutely nobody, but it somehow seems even funnier that I wasn't even recording. So I was just talking into a computer screen, and nobody was recording. Nobody was listening, of course, to what I was saying, and it wasn't being recorded. Visually, if you walked by my office, you couldn't tell the difference, but it just seems really funny. Somehow funnier that I wasn't actually recording when I did that. So here I am. You can tell my eye is red because I guess I'm allergic to just about everything. So, okay, so we're going to look at Introduction to Sympy. So this is like, what you've seen so far would be how to solve things in Sympy. I guess this would be like the prequel to that. Okay, so we're just going to begin by importing Sympy. So import Sympy as SP. So we could just say import Sympy and refer to it as Sympy, but I'm going to use import Sympy as SP, and that way I don't have to type in Sympy, similar to how we do import NumPy. And so as you can see there, I just ran that cell there. Okay, so Sympy is a symbolic calculator. It calculates things symbolically, as opposed to numerically. It also does things numerically. So it computes things symbolically. So what do I mean by that? Well, if you give it a polynomial and you say find the roots, it can actually like find the roots in terms of the coefficients that you've given it. Okay, if you want it to do an integration and actually find the symbolic antiderivative. So if you wanted to find the antiderivative of cosine, it's going to give you sine and not whatever the integral of cosine is from 0 to whatever. All right, so one of the main things in Sympy are symbols. So I'm going to start with x is equal to sp.symbols x. Okay, so what is going on here? In Python, there is a variable called x. What is stored in that variable is a Sympy symbolic variable whose name is x. Okay, so if I do sp, and I can do prettyprint, sp.prettyprint x, what this is going to print is whatever that name is there. So if I run this code, whoops, I got to make that t there. If I run this code, I get x. Now if I change this to a y and I run the code, or sorry, I change it to a yx, but if I change it as a yx, it's going to be a yx. So now what this is saying, in Sympy's mind, yx is now like its own variable. Okay, like yx goes together. Okay, and now in Python, this Sympy variable yx is stored in the variable x. Of course, this is a very complicated, would be a confusing way of doing this. So typically, whatever that is there, we say that's what we name it in Python. So whatever like the symbolic name is, that's also the variable that we'll give it in Python. And so when you run it, we get something like this. Okay, now one of the things in Python or in Sympy is that there are expressions. So I'm just going to call it expression. I'm just going to call it expression is equal to x squared. Okay, when I say x, it's referring to this x squared plus 3x, plus 3x plus 2. This is an expression, and I'm going to print the expression, and when I run this, should have been prettyprint, sorry, when I run this, this is the expression. Okay, so again, this is the prettyprint x squared plus 3x. If I just do print, it's just going to give sort of the computer code. Okay, so whatever you like. This is kind of confusing whether the 2 is a subscript of that or a superscript there, but it's not the prettiest, but there it is. In the next module, we're going to learn how to do LaTeX here, which will make things a little bit better. Now let me just do an experiment. I'm going to put a y there, and let's see what happens to this expression. Okay, so now there's a yx everywhere. Okay, because the expression is equal to x squared plus 3x plus 2. And in Sympy, the x symbol means yx. Okay, let's see what happens if we just print it. And we print it, we're still going to get the same thing. Because this is an expression in Sympy. When Sympy prints it, this is what it's going to print. Or if I do something silly, like Rob is awesome, when I print this, it's going to give that. Okay, well, again, just want to stroke my ego. It doesn't make sense, from a sort of logical standpoint, or having things be readable, it doesn't make sense to have that and that be different names, typically. Okay, so what other things can we do? So let's say we want to factor this expression. So I'm going to say factored and use a very sort of intuitive command, sp.factor. So it has, Sympy has a command called factor, or a function called factor, and we're going to factor the expression, and then let's have us print this. Once again, I don't know why I'm doing the... Okay, and so there we get the factored expression. Okay, and then on the other hand, let's say we have some factor that we can't, some expression that doesn't factor into real numbers. So let's just do this as 200, and let's see what happens when I run this. Okay, well again, what we get back here is just the expression itself, because it can't factor it over real numbers. And there's other things that you have to do if you want to get it factored. If you want to get it factored over, over complex numbers, or if any sort of algebraic field extension or whatever. Okay, so this is really just this sort of introduction to doing symbolic things in Sympy is all I wanted to accomplish in this video. In the videos after this, you might have already seen, those videos are where we're going to do stuff with Sympy, like solve equations, symbolically integrate, symbolically differentiate, and that sort of thing.